Bismillahirrahmanirrahim. Assalamualaikum and good morning everyone. This is Physics 2 DC circuit analysis. Let's say we have a battery and we have some resistors in the circuit. The battery is 12 volt. Let's say the resistors are 1 ohm, 2 ohm and 3 ohm. We can readily combine the three resistors into one by just adding the resistance because they are in series, and so 1 plus 2 plus 3 is 6 ohm. So we can remove this and also remove this, and we have a 6 ohm resistor, and then we can apply Ohm's law. Ohm's law is we want to find the current. I is equal to V over R, so it's 12 over 6 is 2 ampere. Is the current that goes through the circuit. Let's say we have another. Let's say we have another resistor here. Let's say it's a 3 ohm resistor. Okay, let's have another resistor here, a 2 ohm resistor. Now we cannot readily combine this resistance with this resistance because there is another resistance in parallel. We need to combine this first. So let's say this is 3 ohm. 3 ohm. So to combine these two, we need to use the formula 1 over Req equal to 1 over 6 plus 1 over 3, and this is equal to 1 over 6 plus 2 over 6, 3 over 6, or half. So this means R equivalent resistance is equal to 2 ohm. So we can replace all this with just a resistor with resistance of 2 ohm, and then we can combine this because these two resistors are in series. So combining these 3 plus 2 is 5 ohm. So we can remove this one. And so in this case, I would become 12 over 5, and we have the current that is going through the circuit is now 2.4 ampere. Okay. Let's say we have another resistance in parallel. Let's say this is what 10 ohm. Okay, what is the current going through here, and that is going into this junction, and also this is, let's say this is I1. What is I2, and what is I3? Okay, we can solve that we can solve for I1 by combining the like we did here. Okay, and then we can find I3 and I2 by using the junction rule and the loop rule. Okay, so let's see how. First we find I1. So to find I1, it is we need to combine the two resistances. So it's 1 over 5 or 1 over 10, and we will get, this is going to be 2 over 10 plus 1 over 10, and we will get 3 over 10. So the equivalent resistance is going to be 0.3. No, it's the other way around. It's 10 over 3, or 3.33 amp. Okay, so that is 3.33 ohm. Okay, that is the resistance, the equivalent resistance. So we can find I1. I1 is going to be voltage over resistance, the equivalent resistance. So it's 3.33 and it is equal to 3.6 amp.
Yeah.
Okay, we have found I1. I1 is 3.6 ampere. Now, how to find I2 and I3? Now, we got to apply the Kirchhoff's law. For junction rule, we can apply that here. So we can have an equation to describe that all currents coming in will comes out. So I1 will be equal to I2 plus I3. I1 coming in, I2 and I3 coming out of that junction. And to find I3, we can apply the loop rule for this part of the circuit. So we can put an arrow, a curved arrow there in this direction. Why in that direction? Because we know that the current is flowing that way. So in the same way as the arrow. So all the voltage drop across the around the loop will be equal to 0. And so we can put the equation for that loop 12, and there is no other component except this resistor, and for a resistance there will be a voltage drop, so it's going to be negative, minus 5I3 equal to 0. Okay, and then we can solve for I3. I3 is going to be equal to 12 over 5 is 2.4 ampere. And then we can put that in the equation. We already know what is I1. I1 is 3.6, so 3.6 equal to 2, I2, we don't know what is I2. I2 plus 2.4. So I2 will be equal to 1.2 ampere. Okay, so we have solved for the current going in is 3.6 ampere, I2 is 1.2 ampere, and I3 is 2.4 ampere. Okay, thank you.